Algebraic expressions. You need to write these definitions down in your notes. And if we need to come back, we will. The first definition, a variable. The underlined words are the words we are defining. A variable is a symbol, usually a letter, that represents one or more numbers. If you're talking about a one variable expression, what's the one variable we use most often?
X.
X. Okay? But it can be any letter, A through Z. O is probably not a good choice because it could look like a 0. All right. So we'll see X most of the time if you're talking about one variable. If you're talking about two, it could be X and Y, A and B, whatever. An expression that contains one or more variables is an algebraic expression. Who wants to give me an example of an algebraic expression? Dobbins.
1 plus X.
Very good. Notice how he stopped right there. Yes?
Parentheses, X times 2. Parentheses. Would that be an expression?
That's an expression. Okay. Make sure you don't put an equal to sign in there. What's the equal to sign make?
Equation.
An equation. Right. So that's the difference between an expression and an equation. And the last definition, substituting numbers for variables is evaluating an expression. And that's what we're going to do in the first example you'll see. Okay. Here, evaluate. The first line is our example. Evaluate a minus 2b plus ab, for a equals 3 and b equals -1. And the work below that is how we get to our evaluation. So all I do is substitute the values in for the variables. A is 3, and you need to be very careful. We need to make sure we use orders of operations. All right. The 3 goes in for A, so I have 3 minus 2. B is -1, it tells us, plus 3 times -1. Then using orders of operations, I simplify. 3 plus 2, because I multiply -2 and -1. And then 3 times -1 is -3. That simplifies to +2. Question. Next one, evaluate the expression. -x squared minus 2 times x plus 1. Again, what I would do first is just take what they tell you x is and plug it in. They tell you x is 3, plug it in. So I plug 3 in here, 3 in here. Now this is where you need to be careful. We talked about this a little bit yesterday. -3 squared is different from if I had -3 in parentheses and squared that. What is -3 in parentheses squared?
-9.
-3 in parentheses squared is +9. Okay, but -3 squared here, I square the 3 first to get 9, then I take it
I thought
in.
you said
Okay. -2, 3 plus 1 is 4. Here, make sure we multiply here. Don't combine these two first, because we wouldn't be using orders of operation. So I do -9 minus 8 to get -17. Okay. Couple more definitions. Write these down. A term is a number, a variable, or the product of a number and one or more variables. What two mathematical operations separate terms? What'd you say?
Subtraction,
And
addition.
addition. Those are the only two, not multiplication and division. All right, it's all considered one term if you're multiplying or dividing. You have to have addition or subtraction to separate terms. The number in front of a term is the coefficient. If I had 3xy, how many terms is that?
2, 1,
One. There's no addition, no subtraction, right? That's one big term, 3xy. I put plus z, now how many terms?
2.
Two terms. What are your coefficients of each term? What's the coefficient of the first term?
3.
3. What's the coefficient of the second term?
1.
Okay. Next example. Simplify the expressions. There are three different problems, A, B, and C. A and B was one step and you're done. C we needed to simplify a little bit. So, the first one, 3k minus, what's understood to be in front of the k? 1. So 3k minus 1k is 2k. Question on that? All right, next one, just because you have the same variable doesn't mean you always have like terms. Z squared and z are not like terms, so we cannot combine those. So we have to stop right here. So you want to combine your z squareds. 5z squared minus 8z squared gives you negative 3z squared. Right? Negative 10z plus 1z gives you negative 9z, and you cannot go any further with that. Okay. That does not equal negative 12z cubed. All right, so make sure you stop right here. Here, like I said, we need to simplify the expression by distributing the negative. So we get negative m minus n. Distribute the 2 to get plus 2m minus 6n. Make sure you distribute these throughout. Make sure you take this negative to both terms. Alright. Then from there, combine like terms. What's negative m plus 2m? 1m. Negative n minus 6n, negative 7n. And you're done right there. Okay. One more example. Draw this figure to the best of your ability. Note what's underlined down here, not drawn to scale. You'll see that a lot when you're taking tests. It'll be in your book as well. And it's pretty obvious here because B, B, and B don't really match up same distance when they should be. This top segment up here and here, the length of that is 2a minus b over 2. And we are asked to find the perimeter of this figure. What is perimeter of the figure?
the area, the length of the.
So the edge, length of the edge and the outside,
The distance
around the outside.
around the outside. Okay, distance being the key word. The distance around the figure. All right, so all you do is add up all the sides. And where I started over here to the left with A, and just went counterclockwise with all the sides. So you get A plus 2A plus A plus 2A minus B over 2 is right here. Plus B plus B plus B plus 2a minus b over 2 again. And then you have to simplify that just like we were in the previous example. So combine like terms, and I sort of separated the fraction, put those two together. I combine these here, a plus 2a plus a is 4a. B plus b plus b is 3b. And how many of these do I have?
2.
That's why I just rewrote it like this. 2 times 2a minus b over 2. Okay. You could do it that way, or you just could combine them because you have the common denominator. So you could just combine the numerators if you wanted to. The reason I did this is because what happens to the 2's here?
Cancel out.
They divide out, right? And what are you left with?
A minus
2a minus b. So what's 4a plus 3b plus 2a minus b? 6a plus 2b. Yes?
So you're saying the final parameter, you just gotta add around the whole thing to get the answer?
You add up all the sides to find the perimeter. That is correct. Okay?